But our next example is going to be about a mass hanging from two strings. And we often have masses hanging from two strings. So, example 2. Now, for those of you who do and don't do physics, we often use the words light inextensible. I should say 2 light inextensible strings.
Do we assume the string is weightless?
All right. So, Emmanuel, as always, is 2 seconds ahead of my voice. Light inextensible says no mass, which is important because we've got 5 kilos and everything that has mass will have gravity. So by saying it's light, we're just assuming no mass. And inextensible means that there's no stretch in it at all. Okay? Now, the reason it's really important for no stretch, has anyone ever hung something off a piece of elastic? Put something on some elastic and what happens to the elastic? It stretches. If it's stretching, we're moving. We don't want to be moving. We want everything to be beautifully in equilibrium. Okay? Now this question comes with a diagram, and here's the diagram. It's got a lovely ceiling. It's got 2 strings. Where's most of mine? There's my mass. Okay. And often your questions will come with a diagram. Even if they don't, we need to do our first step, which is to make a force diagram. We're going to do our force diagram 2 ways. Firstly, we're going to pick up this diagram and just put all the forces in it that we know. The first force we know is that we've got some sort of mass here, and we have to have mass times gravity acting straight down into the earth. We okay with that? There's 2 other forces acting on this mass. One of the forces is in this string, and we're going to call it tension 1. And the other force is in this string, I'm trying to make them look like they're at different angles, and it is tension 2. For the point of our mass diagram, or our force diagram, don't worry too much about scale, because you've got no idea what T1 and T2 are. Is everyone happy that we've got 2 strings holding up this one weight, and how I got this out of here? Few more details. There's my vertical. This angle here is 45, because this angle here is 45. This angle here is 60, because it's not 30, it's this angle down here. 45 kind of disguises things, 60 doesn't so much. We're going to take this diagram, and probably here, we're going to turn it into vectors in a specific direction, into components. Now, the obvious components for this particular one are vertical, and then you have to go 90 degrees to that, so horizontal. So we're going to convert them into those 2 components. All right, so let's redraw our diagram. Yes, again. Now, I can leave this as mg, or if I wanted to, I know that mass is 5 and I know that gravity is assumed at 10, so I could change this into 50. It's up to you. 50 straight down. My green triangle here, if I resolved it into its components, looks like this triangle. Do you agree? So it has a green component up and a green component to the right. Can anyone tell me what each of those components is in terms of T1? T1, which is this one here, or the magnitude of T1, cos 45 is my vertical component. Now, technically, guys, these should have magnitude lines around them, but they become very clumsy within. Okay? This direction, T1 sine 45. Or you could say T1 cos 45 as well, because it doesn't matter too much. For our orange, I'm just going to make it slightly smaller. I also have a vertical and a horizontal component. This time I have two angles, 60 and 30. It doesn't matter which one you use. So if I resolve it into its two components, who wants to have a go of that in terms of T2? T2 cos theta is cos 60 is our vertical, and T2 sine 60 is our horizontal. You could also say cos 30. It doesn't matter, except sometimes they do those helpful things where they say show and they have it all in coses. If that was the case, make them all in coses. If it's not the case, it doesn't matter. These are all very carefully exact angles. So it's a bit ugly, but we're resolved into two orthogonal directions. To find our tension in the string, we've got one unknown, two unknowns, so I'm going to need two equations. I need two equations and I've got two directions. So this comes back to the sum of the forces in the x direction is equal to 0. If that's true, then T2 sine 60 has to equal T1 sine 45. And I will put my magnitudes in there at this point. Do you agree? I could also write this as T2 sine 60 minus T1 sine 45 equals 0. Same thing. Because I'm in opposite directions, I can work them through. The sum of the forces in the y direction is also equal to 0. That means up, I have T1 cos 45 plus T2 cos 60. And if I wanted to, I could write minus 50 because it's in the opposite direction equals 0. Or I could just jump to this. I now, luckily, have two equations and two unknowns. And we know how to do this. How do we do this? Simultaneous equations. What's one that looks reasonably good? Not quite good yet, but I can make it like spot on perfect.
T2 sine 60 equal T1 sine. Wait, no. Wait.
What's the problem? Yes.
Yeah.
We can do this. Or we could convert it into 1 on root 2. It doesn't matter. Why is that useful? Because then it's exactly this. So we're now going to sub 1 into 2, and I get T2 sine 60. Remember, we know what sine 60 is, plus T2 cos 60 equals 50. That gives me T2. What is sine 60? Sine 60? Root 3 over 2. Cos 60? Half. So that gives me the magnitude of T2 being, now this is, you can do it in exact form. Let's go to 1 decimal place, just for convenience. Calculators out, what did we get? 100 over 1 plus root 3. If you're putting it into your calculator,
36.6.
which is approximately 36.6 watt. Newtons, because it's a tension in a string, it's a force. How could I find T1? We're all very alive today. Sub into 1, which is going to give me approximately, I'll put it in an exact value, times cos 45, which is 1 on root 2, equal to T1 times cos on 45. T1, see if you can get it for me in one step because I'm all the way down the bottom. Approximately I've got a 36.6 times root 1 on root 2. I got the right thing? No, I seem to have done something wrong. Hang on.
Sine 60 is not one of
Yes, sine 60 is not. Sorry, I was reading here.
Sine 60 is root 3.
Root 3 on 2. There we go. Have I got the right rest of it? Yes. I merged one equation with another. Answer?
45 something.
45 something.
Around it.
Anyone else? 44.8. They will probably tell you the roundings that you can do. How do we feel about this? All right. I'm really happy for you guys to go on and do some work on those now. I've got one last example, which is our inclined plane, but we can leave that one for tomorrow. I think we should get started and do some work on your own. Yes? How happy are we feeling with being able to do that? Diagrams are key for those who don't like doing them. All right? If you can't make it into a nice component diagram, then we are going to run into issues.